Hello fans, here I am back in my local park. A lovely day, lovely weather, and a lot has to do with quantum mechanics. I never knew this, but quantum mechanics. Let me tell you a little story. Starting about 1865, where a man named Anders Angstrom, in his laboratory in Uppsala, took a spectrum of hydrogen, the gas hydrogen. I've tried to explain that a spectrum is the breakdown of colours of a light source. The light source could be the sun, and the breakdown of the colours could be what we call a rainbow. Now, hydrogen does not have a rainbow. It has 4 distinct colours in the visible region, and it took a long time to explain this. It was not possible to understand what was going on. A man named Janne Rydberg in Lund, about 600 kilometres from Uppsala, explained this using integers. Rydberg's formula had 2 integers, n1 and n2, but no one knew what did these integers mean. Rydberg was a mathematician. It then took another 20 years or so before a man called Niels Bohr in Copenhagen, about 30 kilometres from Lund, built up a model of hydrogen called the Bohr model of hydrogen, where he said, in hydrogen, you have a nucleus, much along the lines of the work of Rutherford, and outside that nucleus, you have 1 electron which is spinning around in hydrogen, and that electron cannot spin anywhere. It has well-defined paths, very well-defined paths. It cannot go between, so it follows a path, and these paths represent energy in the atom. N equal 1, which is the path closest to the nucleus, n equal 2, n equal 3, and light, the colours, was coming from transitions between n equal 3 to n equal 2, for example. The electron cannot be in between. This is quantum mechanics. It's not understandable in the terms of classical mechanics. In classical mechanics, an electron circulating in an accelerator like a synchrotron, when it goes through the magnet, it bends. That is an acceleration. That means it's changing velocity, because velocity is a vector and has both a number, how fast, and a direction. To change velocity means it loses energy. And the electron in hydrogen, if it were classical, would spiral into the nucleus. All matter would just collapse. There would be nothing left. Luckily, the world and the universe is governed by quantum mechanics on the small scale, and everything is stable. Wonderful, isn't it? Physics, wonderful. Thank you.